Hello everyone, this is Gurpreet Kaur Khanuja. My topic is grid computing and which is submitted to Mr. Dr. Vivek Srivastava sir. Introduction to grid computing. Definition. Grid computing is a distributed computing model that involves pooling together resources from various computers across different locations to perform large-scale tasks collaboratively. It means when you have a complex problem and you have to solve that problem, so we have different locations, we have different resources on different locations. We use all the resources collaboratively to work on the same problem, but that one problem is divided into different subtasks. The key concept behind is this: grid computing enables the sharing of computing power. In this, the computing power is shared, storage is shared, and data across multiple machines is also shared. And it is used to solve a complex problem that requires significant computational power. What are the characteristics of grid computing? Decentralization, resource sharing, parallel processing, scalability. Decentralization means resources are distributed and managed independently across various locations. Resource sharing means utilizes the idle resources like CPU, memory, storage from multiple computers. It enhances the overall computational capacity. In parallel processing, we have tasks which are divided into smaller pieces or smaller subproblems and processed concurrently by different machines on the grid. In the scalability, we have new resources can be added easily as the need for computing power increases. Means if you have a complex problem and you have 4 computers to solve that problem and your problem size is increasing, then you can easily scale up your resources by adding one more machine to your resource. How grid computing works? The grid computing works by 4 major tasks: the task division, resource identification, parallel execution, and task aggregation. In task division, we have the steps that we divide the large task into the smaller broken parts and independent subtasks. Resource identification: in this, available computers or servers on the grid are identified for task execution. Parallel execution means that subtasks are processed simultaneously across multiple machines. In task aggregation, results from different machines are collected and combined to produce the final output. Types of grid computing. Computational grid. It focuses on the providing raw computational power from distributed system. What is data grid? Data grid deals with the management and sharing of data, large data sets across a grid network. Collaborative grid, it means support collaboration among users, allowing them to share software, data, and tools across the grid environment. What are the applications of grid computing, or where the grid computing is used? Grid computing is used in scientific research, financial modeling, healthcare, environment, or entertainment. In scientific research, we have simulation, modeling, analysis in physics, chemistry, bioinformatics. In financial modeling, we have risk analysis, forecasting, large scale data processing, just like for banking and finance. In healthcare, we have genome analysis, disease simulation, and drug discovery. In entertainment, we have a lot of graphics for movies, games, and animations. Benefits of grid computing: it is cost efficiency, is resource utilization, scalability, and high availability. In cost efficiency, we using existing resources, so we are not enabling or supercomputers, or we are not using supercomputers which are very high in cost. So in this way, we are it is cost efficiency. And resource utilization means efficiently using the idle resources, means the machine which is not used by us, it is using for solving the complex problem and making the most of existing infrastructure. Scalability: grid systems can easily grow by adding new computers to the network. High availability: grid computing resources continue availability of resources by distributing tasks across different multiple machines. Challenges: the challenges are 4. The first one is security. Sharing resource across a distributed network can expose system to security vulnerabilities. Means if one task is distributed among various machines, then the task is divided, the security is healed, and the security breaches. In that, if the security is breaching, then it's a high vulnerable. And resource management: in resource management, managing a grid with multiple autonomous resources can be a complex task, because we have different machines in which the task is performed. Network dependency: performance is often limited by network speed and connectivity. If one machine is a slow machine and others are fast, the fast machines has done their work and waiting for the slow machine to complete their work to aggregate the following and final output. Heterogeneity: in heterogeneity, we have a grid environment that involves different type of hardware and software which can be introduced compatibility challenges. We have different machines to work that task. If the one machine's hardware is different from another machine's hardware, then there is a compatibility issue to aggregate the task or aggregate the output. The real world examples of this are CT at the rate home. It uses computing to analyze data for search of extraterrestrial intelligence, that is SETI. And CERN, the Large Hadron Collider (LHC), uses grid computing for data processing in particle physics, or just like atomic physics. We know that in atomic physics we need extra calculations and extra complex calculations, so we need supercomputers to solve that problem. We are not using a supercomputer. We are combining many simple machines or many personal computers, computing resources or power to solve that complex problem. Folding at the rate home, a distributed computing project that is folding at the rate home. It is aimed at simulating protein folding to understand diseases like Alzheimer. To understand the diseases like Alzheimer, we need to structure and we need to analyze the protein structure. We know as the protein structure is a complex problem. So to solve that complex problem, we have different solutions. The first solution is that to use a supercomputer that is extra large and extra have the efficiency and is more costly. So to avoid that, or to solve that problem with the existing resource, we uses the different machines and collaborate them to solve that problem. In conclusion, in the summary, we have grid computing is a powerful tool for distributed resource sharing. It enables an organization to solve large-scale computational problems efficiently. Our key takeaways: by combining decentralization resources across multiple locations, grid computing offers scalability. It offers flexibility, cost effectiveness with application in various fields such as science, finance, and healthcare. Thank you.